Okay, this is section 3.4. This is slopes and forms of linear equations. So in this section, I think you'll find this one pretty easy as well as the last couple have been. Just basically stuff you've done since probably Algebra 1. So in this section, we're going to look at slope, finding slope from 2 points, slopes of horizontal and vertical lines, which we've kind of already touched on a little bit of graphing horizontal and vertical lines. Slope-intercept form of a linear equation, writing the equation of a line using point slope. And so those are some of the things that we're looking at in this section. So, all right, so we start with the slope. And so slope of a line, the diagram here kind of demonstrates, we know that slope of a line is the ratio of rise to run. It's basically a measure of the steepness of a line. We know that if the line is increasing from left to right, that it's a positive slope. If it happened to be decreasing from left to right, then it would be a negative slope. But the difference, if you know 2 points on the line, you can find the slope because you can find the rise and the run between those 2 points, or the rise, which is basically the vertical change, and you would find the vertical change by subtracting the y coordinates, since that is the up or down motion of the point plotting. So the distance from here to here would be the distance if this point is up at y1. This is y1, so this is y1, and this is y2. So whatever those 2 points are, by subtracting to find the distance between those, y2 minus y1 would be the. Now I should. Okay, then the distance from this point to this point, the horizontal distance between these 2 points, this would be the same x value that this point has, which is x2. So this would be x2, and this is x1. So again, by subtracting x2 minus x1, we get the distance from this point to this point, which is the run. And then, of course, the slope, which is the ratio of rise to run. You'll often see it written as delta y over delta x, which means the change in y to the change in x is given as y2 minus y1 over x2 minus x1. All right, so this, if you have 2 points on the line, is the formula that you would use to find so much like distance, basically we do the same, we need the same things for distance. We need the vertical change and the horizontal change. And I showed you kind of a quick way, rather than having to memorize a formula, is just to find these two lengths. And then instead of doing rise over run and making a ratio out of it to the distance, you would do a squared plus b squared equals c squared and solve for c. So very much the same components that you use to find slope, you use to find distance. All right, so let's go through just a few quick examples and look at just writing the slope. So I'm going to say slope equals, so this is, if you want to label those, so x1 and y1 and x2 and y2. And there's nothing special about, could this be x2, y2, this be x1, y1? Absolutely, it makes no difference. It's just kind of 0.1 and 0.2, whichever one you want to call which. But the main thing is that the rise is the difference in the y values. So when I do the y values, the difference has to go on the top. And all right, and then the x values gives you the run, the difference in the x values. So from 2 to -4, or -4 to 2, however you think about it. All right, so again, there's nothing special. I could do -3 minus -5 as long as I do -4 minus 2. It makes no difference what order, as long as I do them, the same, the y's in the same order as the x's and vice versa. So -5, subtract -3, so that's -5 plus 3, which is -2. 2 minus -4, 2 plus 4, which is 6. So I'll go ahead and simplify that down and reduce it to say, so basically that tells me that these 2 points, the line that goes through those 2 points, every time x goes up 3, y drops 1. So this is a down sloping line at that ratio, that rate. All right, this one, again, I'll do y So throw some fractions in here this time. This is a negative 4/3 minus 1 over 1 minus 3/2. So y minus y over x minus x. As long as I do the negative 4/3 first in the numerator, I need to do the 1 first in the denominator. I did. All right, so I'm going to think of this as negative 4/3 minus 3/3, since 3/3 is 1, and that makes it easy to compute since they have the same denominator now. Down here, I'm going to think of this as 2/2 minus 3/2. All right, so this top gives me negative 7/3, and the bottom gives me 2 minus 3 is negative 1/2. All right, so remember a little elementary math again. If you're dividing a fraction by a fraction, keep, switch, flip, or however you learned it, this numerator doesn't change. Division changes to multiplication. You flip this one over, and we end up with 14/3 as our slope. All right, and so that means that the line is increasing. Every time x goes up 3, y increases by 14, so it's a pretty steep line. All right, the last one, kind of used all my space for number for b there. 7 minus 7 over 1 subtract negative 2. So 7 minus 7 is 0. And one, of course, it doesn't really matter what the bottom is. So 0 divided by anything is 0. And so that is my slope. And we know that if you have a slope of 0, that means there is no rise. So the line will be flat. It'll be horizontal. So make a little note here. This is a horizontal line. Okay. All right, that kind of carries over to the bottom where of page 1 there, where the slopes of horizontal and vertical lines. So again, horizontal lines, we've seen from the previous section that when the equation is in the form y equals c, I'll highlight that. Remember, this indicates, we know from this it's going to be a horizontal line when there's the absence of x and there's only a y, and a vertical line if there's an absence of y and there's only an x. So x equals a number is vertical and y equals a number is horizontal. We had that in our last section. Now we can add to that if it's a horizontal line, the slope is 0. If it's a vertical line, the slope would be undefined. And let me just kind of, let's just think about that for a second. Let's say you do have a horizontal line between 2 points. So the run, so the rise to run, well, the rise, there is no rise, so this is 0. The run, we'll say that's a distance of n, and then 0 divided by anything is 0. So the horizontal line will have a slope of 0. All right, similarly, a vertical line, let's say there's 2 points in the vertical line here, will have a rise, but no run. So it would be n over 0, which we know is undefined. You can't have 0, and the denominator can't divide by 0. So a vertical line has an undefined slope. Okay, so this next section, finding slope from a linear equation. So basically, when we know that when we graph a line, we usually want it to be, we've learned different forms. We learned standard form, and but we usually want the slope-intercept form, which is called, this is the y equals mx plus v form. Called that because when it's in this form, you can see the slope and the y-intercept, where we know where it crosses the y-axis, and then we know the rate of change of the line. We know the slope. So that's all we need. That's plenty enough information to be able to graph the line. So we're not graphing these, but it does ask us to find the slope of each one of these lines. So the first thing I would do would be to write it in the slope-intercept form. So that just means solve it for y. All right, so we can do that. Let me subtract 4x over. All right, so I would have negative 3y equals 12 minus 4x, or negative 4x plus 12. It makes no difference. I just wrote it this way because it's kind of follows the mx plus b format. But if you wrote 12 minus 4x, same thing. If I divide by negative 3, divide all the way through by negative 3, y equals a negative over negative we'll go ahead and drop those and just say positive. And then a positive over negative makes that y-intercept negative. So the slope of that line is 4 over 3. I'm just going to box it in there. But if I were graphing it, I would know that I would go down 4 on the y-axis, and starting from there, every time x goes up 3, y would go up 4. So it's going to be an upsloping line at a rate of 4 over 3. Okay, this one. I'll subtract the 2x over. So I have 7y equals negative 2x plus 9, or 9 minus 2x, same thing. Then I'll divide by 7. So y equals negative 2 over 7x plus 9 over 7. And so this time the slope is negative 2 over 7. So this would be a down sloping line from left to right. It would be falling from left to right, however you want to think about it. Every time x goes up 2, y would drop 7. And that gives you the rate of the line. You can kind of visualize the steepness of the line by knowing those two components, the rise and the run. All right. What about this one? Looks a little different. And this one I can't even put into slope-intercept form because it doesn't even contain a y. And so this one is one of the special cases. This is a vertical line. So the slope, we know on a vertical line, is undefined. All right, and then this one, of course, is a horizontal line. We know that from our previous section. So I could think of it as y equals 0, x plus 9. But at any rate, the slope is 0, and it's a horizontal line. So slope would be 0. All right. Continuing on with slope-intercept form, let's look at kind of going the other way with it. So instead of being given the equation and you being asked to find the slope, this time you are actually given you're given some information and asked to find this one wants us to actually go ahead and graph. So it's the same thing we did here. So we're going to go ahead and graph it. And I thought it was the same equation as A, but it's not. It's got a 6 here. All right, the second part of this asks us to, okay, both of these ask us to graph them. So, there's no graph, so we're going to make our own graph. It's okay. All right, so use the slope-intercept form of the line to graph the equation. So we're basically doing the same thing we did above, except we're going to go ahead and graph it. So I would get it into slope-intercept form first. Okay, so negative 3y is equal to negative 4x plus 6, or 6 minus 4x. And then I would divide by negative 3 all the way through. All right, so I have y equals 4/3 x, and then positive 6 over negative 3 is negative 2. So I'm going to box it in. That's my equation in slope-intercept form. So let me just sketch a little graph here, and let's look at what the graph would look like. All right, so with the y-intercept of negative 2, I would start from there. I know the graph is going to cross the y-axis at that point. I know now, once I know one point on the graph, I know a starting place, I can use the slope, the rate of change there, to find another point. And all I really need are 2 points. Again, only one line goes through 2 given points. So 2 points determines the line. That's all I need. So as x goes up 4, y goes up 3. So up 4, x goes up 4, y goes up 3, and the line would look like, that would be a line that crosses the y-axis at negative 2 and has a slope of 4 over, actually I did that backward. I did 3 over 4. So let me fix this. Okay, glad I caught that. So negative 2, it's a rise over run, so I need to go up 4, so I need to go over 3 up 4. And so it's a little steeper than what it was. Okay, but 4 is the rise, 3 is the run. Okay, so in B, it says to find the equation of a line that passes through the point 0, 3 and has a slope of 3, 5, which is really not any different from what we did right here. So this is the graph. This is A. I'll do B over here just since I don't have any room below it. All right, so if the line if it contains a point 0, 3, that actually is on the y-axis. So there's the point 0, 3. And it has a slope of 3 over 5. Let me get this out of the way. Rewrite my way of plotting points. So this point is 0, 3. And from here, as long as I have 1 point on the line, the slope is all I need, because from there I know I'm going to rise 3 and run 5. 1, 2, 3 over 5, and that is the slope of 3/5. This would be 5, up 3, and that's the line. Okay. All right, the final part. Writing this in this section, we'll be looking at writing the equation of a line. So you want to be able to write the equation of a line given any components of the line they give you. Maybe they give you the y-intercept and the slope. Maybe they give you the slope and another point on the line. Maybe they just give you 2 points on the line. Sometimes they give you the slope, or they give you a point on the line and another line that's parallel or perpendicular to it. So whatever cases you're given, you want to be able to write the equation of a line. Bottom line is, you need to know the slope and the y-intercept to have a equation of a line. We've looked at standard form of a line, of an equation of a line. We've looked at slope-intercept form of the equation of a line. And now we're going to look at the third type of equation, which they call point-slope. So this equation, slope-intercept form is called slope-intercept form because you can see the slope and you can see the y-intercept by looking at the equation. It's in that form where you can just look at it, you know what the slope and the y-intercept is. Point-slope is basically what it says as well, point. So the x1, y1 part of this is a point that is on the line. So x1, y1 this is any point could be any point on the line. And the slope is also seen in the equation. So you can see the slope and you can see a point that's on the line, and that's why it's called point slope. And that's what you need to know. So if you know a point on the line and the slope, that's all you need. And this will give you the equation. And then you can manipulate the equation algebraically to put it in whatever form you want it in. If they want the answer in the equation written in slope-intercept form, you can easily do that. If they want it in standard form, you can easily do that. All right, so let's look at a few examples. So the first one says to write the equation of a line that passes through the point. So it gives me a point, and it gives me the slope. Okay, well, that's what I just got through saying, is that you need two things. You need to know the slope, and you need a point on the line. We got both. And so I literally am just going to plug in, this is my x1 and my y1, and I'm going to plug those as well as the slope in and simplify it. So I would have y minus 5, that's y1, equals m, which is 3, my slope, times x minus negative 2. That's my x1. And then I can say y minus 5 equals 3. Let me go ahead and change minus and negative there, x plus 2. If you want it in slope-intercept form, I can just distribute the 3 out and add the 5 over. So I have y equals 3x plus 6 plus 5, or y equals 3x plus 11. So there is slope-intercept form. This one doesn't specify how to write it. But if they said, sometimes they will, express a line in slope-intercept form. If they said express a slope-intercept form, if they said express it in standard form, remember that's when we want the x term, so we would want the x and the y term on the left and the constant on the right, and so that would be the standard form, just by subtracting the 3x over. So it just depends on what form they want the line in. All right, the second one says write the equation of a line that passes through the points -3, -2, and 1, 6. All right, so before I can use the point slope form, I have a point on the line. I've actually got 2. I only need 1. I can use either one of them. It doesn't make any difference which one I use. Any point on the line will do. But I need the slope. So going back to the very first thing we did, we know how to find slope. y2 minus y1 if you have 2 points on the line. So I need to do this first to figure out what the slope between these 2 points is. So I'm going to say 6 minus negative 2. over 1 minus negative 3. So 6 minus negative 2, which is 6 plus 2 is 8. 1 minus negative 3, which is 1 plus 3, which is 4. And my slope is 2. All right, and so then I can use, now I've got everything I need. So I pick one of my points, I'll just use the 1, 6 point. So I'm going to go with a slope of 2 and 1, 6 being my point on the line. I could use this one just as well. I can then plug into my slope-intercept form. So y minus 6 equals 2, that's my m, times x minus 1, that's my x1. So y minus 6 equals 2x minus 2, and I'll add 6 over, and y equals 2x plus 4. And again, if you want it in standard form, that's it. If you want it, if you want it in slope-intercept form, there it is. If you want it in standard form, I would subtract the 2x over and write it as 2x plus y equals 4. So it doesn't specify, again, but I think in Hawks on some of the certification problems, it will specify what form to write it in. All right, so that pretty much wraps up what's in this section. You're going to be working with slope, graphing lines, writing the equation of a line, and just to summarize at the end, the different forms of the equation that we've talked about. Your linear equation can be put into basically 3 different forms. You can, standard form just means the x and y are on the left. That we use that one in previous sections. Slope-intercept form, y equals mx plus b. If you're going to graph it, this is your form you usually want it in. And if you're trying to write the equation line, either one of these could be used, but this one is certainly handy as if you know the slope and a point, pretty easy to plug into that. And then you can manipulate this into whatever form, whether you want it in standard form or slope-intercept form.